Hello guys, today we are doing a Millikan oil drop experiment and here comes the data. So now we are going to collect data. So what you are seeing is actually the screenshot of the microscope image of the Millikan chamber. We haven't started putting oil drops yet, so you will see it in a second. But before we start, Professor Bird, could you tell us what our voltage for our capacitor plates will be? For our parallel plates?
Yes, the positive plate will be the top plate, which means negatively charged oil drops will be accelerated up. And when we turn on the voltage, it'll be 130.1 volts.
Okay, if you couldn't hear that, I will tell you again. So the top plate will be positive, and it's going to be 130.1 volts. So 130.1 volts.
With respect to the bottom plate, yes.
130.1 volts. And Professor Burke, what's our thermistor reading there for the
thermistor reading, which gives them the temperature, is 1.932 mega ohms.
So the resistance of the thermistor is 1932 mega ohms. I'm sorry, 1.932 mega ohms.
That's right.
That will be too much. Yeah, so once again, the resistance of the thermistor is 1.932 mega ohms. Okay?
Mega ohms, right.
1.932
million ohms.
Okay, so write it down because you need it to calculate the viscosity of the air, because the viscosity of the air changes with temperature.
And they'll need the pressure in there, the barometric pressure.
Oh, yes. By the way, let's look at the barometric pressure quickly before we go any further. So I'll tell you what the pressure is right now. Thank you for reminding.
Yes.
So I'm looking at my barometer app on my new state-of-the-art smartphone. Okay, the barometric pressure is 109,920 pascals. 100,920 pascals. 100,920 pascals, okay? Hey, one more time. The barometric pressure, 100,920 pascals. Okay, now, so I will now tell you how to take data in this experiment. The first thing you need to do, when we put the drops in, you need to look at the same drop. You need to follow the same drop. So you cannot alternate between drops while you are taking data, because, and the reason for that is simple, because every drop is a different radius, okay? So you cannot just use different drops. Besides, they might have different charges on them. So the first step in data taking procedure is to do it without the voltage. So we ground the plates, the voltage is equal to 0. So the drops are falling under gravity only. There is no electric field, there is no electric force. They are falling under gravitation. So you need to determine the speed of the terminal velocity of the drops under gravity. And the way you measure the terminal velocity of the drops under gravity is you look at the divisions on the screen and the distance between the maximum what do you call this?
The bold lines. The bold lines.
Okay, yeah. We call them major divisions, I guess. The difference between the major divisions or the bold lines.
Yeah, from here to here is
0.5 millimeters.
Yeah,
half
and
a millimeter.
Each little square is how big?
So that's going to be 0.1 millimeters.
Okay. So each little square is 0.1 millimeters, but from the bold line to the bold line below it, that's 0.5
millimeters. So what you do, you let the drop go through one major division or two major divisions, and then you look at the stopwatch and you determine the speed of the drop, basically, or the terminal velocity of the drop going through one or two major divisions. You just look at stopwatch and the distance, and then you determine the velocity. That's very important, and that's for free fall. That's without the electric field. And then the next thing we do, you don't lose that drop. You keep looking at that same drop. You need to follow it. When we turn on the electric field, the drop is going to start usually going upwards because there's going to be negative charge and the upward plate is positive, so opposite charges attract. So, and when the same drop is rising, now you need to calculate this rise speed, okay? So the second part is basically to find the rising velocity for the same drop. You do it in the same way that you did for the falling velocity, and then you just keep recording it. By the way, for the same drop, you need to take more than one measurement. So I would say, for example, let the drop go, for example, through 1 divisions, take 1 measurement, and then 2 divisions, take another measurement.
Major divisions.
Yeah,
right?
2 major divisions. So
yeah.
please take more than 1 measurement for the same drop. You can rewind the video or you can pause the video, so you are free to rewind or pause the video, but you need to take more than 1 measurement for the same drop so that you eliminate or you reduce errors, okay? So that's what we will do. And then we need to do this for several charges. By the way, some charges are going to be several electrons, and they are going to go very fast when we turn on the electric field. So you need to concentrate on the drops which go slowly. So you don't want to basically observe a drop which goes to the screen in like 2 seconds. That's not going to be accurate data. We are trying to do an accurate experiment here. So we are hoping to get electron charge within a few %. So if you only look at fast drops, there is no way you are going to have any accuracy. So you want to be able to observe the same particle regardless of whether it's falling or rising for about 10 to 15 seconds at least.
Right. Let me interject here,
sure.
Doctor, if I could. Now, what he's saying is that a good drop would be a drop that, say, goes through 5 small divisions or 0.5 millimeter in like 15 seconds. And then when the field is turned on, it goes up in something like 10 to 20 seconds or something. So that'd be a drop that's moving slow enough and has a small enough number of electrons on it to give you good data. Now, try and remember that when we turn the field on, electrons will be attracted upwards. So electrons that are piggybacking on the oil drop will pull the oil drop up. Some oil drops will actually have a positive charge and they'll be accelerated down. Ignore those. We're not studying those.
Right. So again, ignore the drops which are going too fast. So you need to look at the drops which are going slowly, regardless of whether rising or falling. We might also try to add some extra charge on them by turning the ionization source, but I'm not sure if it's working. Right now, is it in spray position? What position is the...
I have to put it in spray position.
Right, so let's not forget to put it in spray position when we spray.
Yeah, okay.
You
want me to inject the oil now?
We are going to inject it soon, but let me tell the students about the ionization source there, or the ionizing source. The ionizing source, at least in theory or principle, adds some electrons on the drops. So when we turn it on, you might see the drops going faster, the same drop gaining more charge, more electrons, and then going through the screen faster. And then if that happens, then you need to remeasure the speed for the same electron.
Same drop.
I'm sorry, for the same drop. Yeah, for the same electron. Yes.
What happens is as the alpha particles come in, they create collision events with the air and oil vapor, and they liberate electrons.
So we will see if we can also do that. So we are not sure whether that's going to work, that we might be able to add more electrons on same drop. But if we can actually add more electrons on same drop, then you can do more measurements on the same drop for different charges, and then actually find out.
Yes, but keep in mind that when you measure the rise and fall speeds, you want to do that when the ion source is off, because you don't want it changing you don't want the charge changing as the thing's going up.
Right. So we are going to keep the ion charge on for only 5 seconds, and then we will turn it off. And if the same drop gains an extra electron, then it's going to go faster. So that's going to be interesting. Then you can get data for the same drop for 2 different charges, right?
Yes, sir.
All right. So now, could you put the lever on the spray position?
It's on spray position now.
Yes. Spray position ventilates the chamber, so that's lets the pressure out. Okay. So now.
Introduce some oil.
Yeah. Let's look at it. See how it looks like. right, so there's a lot of drops in there, I think, right now. So
Okay, and I'll add drops throughout the experiment as we need them.
okay, could you now turn the lever to the other side?
Ion source?
No, the off position.
Okay, okay.
So it's in off position,
Yes,
right?
sir.
Okay, thank you, Professor Burke. And so now we are seeing now you should be able to actually measure the terminal velocity of some of the drops. And then again, you want to look at some of the drops that which take about 10 or 15 seconds through a major division. So please see if you can actually now you can focus on the same drop through the screen and then measure its terminal velocity. Right now the field is 0, right?
That's correct, yes.
And
You,
then
you want to track a single drop that you like and tell them to start data now, or
yeah.
want to pick a drop that you like. Do it. Make sure you pick a drop to the left, so because these are hard to see over here.
What I will do here now, we have the luxury actually of rewinding the video. So, well, I mean,
Walk them through one measurement.
the thing is now, if I just pick with my mouse, if I pick like one of the drops here, I'm not sure whether it's going to go fast or slow when we turn.
That's right. You got to guess.
Yeah. So. All right. So do you think they had enough time to actually take some readings here?
Well, yeah, but walk them through one drop falling.
Okay. So for example, here let's take. So this one is going pretty fast here.
Yeah. There. Let them count that. I'll observe.
Yeah. I'm showing to you with my mouse here. With my mouse pointer.
Yeah, that's going to be more than 10 seconds. That's a good drop. Now, if we turn the field on and it goes up real fast, then they can't use that drop.
You can also see there's some. Okay, now you need to turn the field on.
Okay, field is on now.
Okay, that drop was actually positively charged.
Okay.
Turn out.
So that was a bad choice. Why don't you pick a drop
Could you turn it off?
Turn it off. Okay.
Yeah. That was too fast.
Okay.
Okay. Could you go next to the control there? So I'm going to tell you to turn it off. I mean turn it on.
The
so
ion,
could you turn it on?
the ion source?
No, the voltage, please.
Yeah, voltage is on. Yeah.
Oh, it's on right now?
No, right now it's on.
It's on now?
Yeah, now it's on. You'll see them going up. There's one going slow.
Okay, so this one is going slow with my mouse pointer, as you see. Now, could you turn it on like in 5 seconds? I mean off?
Yeah. Tell me when.
No?
Right now?
Yeah. Okay. Now we got the same. Now with my pointer here, I caught one of the drops here. So we are observing that one.
Oh, it went up pretty slow and now it's going down pretty slow. That's a good drop for data, right?
Yeah. And then I see 3 more drops clearly in the same shot. So I'm not sure we can take data with those 2, but we have 4 drops.
Well, they can do it. They can start and stop the video, and they can get data off all those 4 drops that are moving pretty slow.
Yeah. So, okay, can you turn it on now again?
Yes, sir. On.
Yeah. See, those drops, all 4 drops are pretty good.
Going up slow to get a speed. Tell me when.
Okay, turn it off maybe. Yeah.
So Dr. Estrogen. So all they need is a rise speed and a fall under electric field and a fall speed under a free fall in gravity. Those 2 speeds will tell them everything they need to calculate the charge on the drop. Is that correct? Those 2 speeds alone?
That's right. So once they know those 2 speeds, they know the electric voltage from the voltage, and then that value, then I can pretty much calculate everything. Of course, they need to know the viscosity and
all the symbols that were given to them
right
in the write-up formula. But basically, their measurement is the speed up under the electric field and the speed down under gravity alone.
Okay, now I see a bunch of drops here. Let's have them. Could you go near the control, please, so that I'll tell you when to turn it on. So I'm following one of them right now with my pointer.
You got like a collection of 4 there, huh, together?
Maybe 5 even. Okay, I'm following this one. So let's see what this one is going to do.
Get way down the bottom of the screen first?
Right. Okay, like in about 5 seconds, I would say. Go.
Now?
Yep.
Field is on.
Okay, now it's going up very slowly. You can barely see it, but we can see it. So it's kind of faint, but we can see it. I'm holding my mouse next to it.
That's a nice big drop with not very much charge on it.
You see it next to my mouse pointer?
Yeah. That's a good data. That's a good data point. We need to make
And
sure
then
we
and
get
then
about
and
10
then
of those.
and then there is another drop here which is going up very, very slowly. That must have a single charge maybe.
Or maybe two.
So let's wait for this drop to go up. So do you think our voltage is maybe a little too low, Doug?
Well, or we could add some charge from the ionization source.
Could you turn on the ionization?
How about we add more oil? It looks like you're pretty short.
No. Turn on the ionization, please.
Oh, okay. Ionization is on.
For like 5 seconds, maybe. I'm trying to see if this thing is going to actually gain any
Sort of
charge.
see how it's shaking in random motion, left and right, up and down. That's called Brownian motion.
It looks like the ionization source didn't have it here, so it still has the same charge.
Yeah.
Oh, turn it off now.
Okay.
Looks like the ionization source isn't doing too much.
You want to add some drops?
The off position is actually it's off, right?
Yeah, it's off. Yeah.
Oh, okay, so all right, so
When they add drops, so they have some more time to collect data, and when they see the acceleration up and down, they know the field went on.
So do you think there's enough data with 130 volts? Should we change the voltage?
We can, or we want to do another data run at that voltage.
Okay, let's do another data run with 130 volts then.
Okay, and then I'll add oil. Yes or no?
Yes, please. Mm-hmm.
Here comes some more oil. Oh, let me put it in the misting position. Let me know when you've got a lot of snowfall in there.
I think that's good. That's good.
Okay.
Oh, the field is off, right? No, it's.
Oh no, the field is on. I'm sorry.
Okay, yeah.
Okay, field is off now.
Oh, that's good. So I think they are going to be able to get a lot of data out of this one.
Yeah, they could rewind the tape and measure several of those drops.
Some of these large drops are falling pretty fast. So
yeah, I see the big ones. The big ones aren't in focus so much, but you can see them like a big jellyfish falling.
And then we are going to turn the field on here so they could take more data.
Yeah, let's let a good chunk of time go by. If we let too much go by, well, they can stop and start within a section of the tape.
But if we wait too much, then we are losing them from the bottom of the
Want
screen.
to turn it on now?
I would think so, yeah.
Field on now. Now some drops will get accelerated downward because they have positive charge.
Let's turn it on, please.
Here it is. Field is on.
And then let's wait for like maybe a minute, and then we are going to change the voltage. We might
drops going up and down now.
We might be having problem with charges, like small charges here, because our voltage is so low right now.
Yeah, well, we'll crank up the voltage. I see a good drop that's going up. Long time to go through one major division. Okay, that's enough, you think?
Yeah.
Turn the voltage off? Okay.
Okay.
Okay. Now, do you want to introduce any more ions, or?
By the way, I'm just want to put a note here, like a notepad, so I could actually write down the voltage here. So the previous voltage was
130.1 volts.
The previous voltage was 130.1 volts.
Yeah.
Now we are going to turn it on.
And the thermistor reading was 1.932 megaohms.
So is the voltage off now?
The voltage is off, yes.
Okay. Now we are changing it to like 300 volts. Let's try 300.
You want to try 300? Okay, I'll crank up the voltage to 300. You sure 300, not 260?
Oh, you want to do double?
Yeah.
Okay, let's do double then. 260
Yeah.
times the exact value.
257.4.
Can you go a little bit higher?
Yeah, you want to go 280?
No, 260, like right around 260.
Very hard. I don't
Okay,
know.
I see.
261.3.
Okay, fine. 260, 261.3?
Yes.
261.3 volts.
And thermistor hasn't changed much. It's 1.926 now, from 1.932 mega ohms. So
Thermistor is, what is it?
1.926 mega ohms.
1.926
mega ohms. Yeah, yeah.
mega ohms. All right. So,
So
could
the
you?
field is big now, 261 something.
Okay, let's put more drops then.
Okay, the field is off. I got to put it in the misting setting. Adding drops. Okay.
Currently free fall.
Good.
So let's wait for maybe 30 seconds here, and then
Yeah, because some of those drops
Or
are
maybe-
taking
maybe
a
a
while
minute.
to go through the whole thing.
maybe let's wait for like another 40 seconds.
Yeah, there's a lot of data there. If they rewind the tape, they can pick the drops that, well, they're going to have to pick the drops that go up slowly. You know? If they pick one that accelerates up real fast and goes, or down real fast and goes off shot, they're not going to get good data. So they got to pick
All
and
right,
choose
I
your
think
drops.
I think we need to turn on the voltage now.
Voltage is on.
Okay, that's 261 volts.
Yeah. Some of them are still going slow. Yeah. Remember, if they're accelerating down, that means they have a positive charge, but it'll still be an integral number of positive electron charges on there. I mean, it'll be because they lost electrons.
Again, remember this is 261 volt.
Yeah, there's some nice, slow, big globules there. Tell me when you want me to turn it off again.
Turned off.
Okay. Voltage is off.
Now they can take more data using the same drops. So now you need to take like more data using the same drops. So please take more than one data.
You should probably edit it, say free fall is when all drops are going down, because it's no longer currently free fall. And delete that currently free fall, because free fall is when all drops are going down. All right? And just in general, free fall is when all drops are going down, and electric field on positive plate, top plate is when drops are going up and down.
Okay, now we need to turn on the voltage.
Voltage coming on right now. Well, that's good. Some of them are moving very slow. The fast ones get wiped out to the plate.
And then I think we turn it off one more time, and then they can take
Are you
like
ready almost?
just a second.
Yeah?
Okay, turned off. So now they can take. By the way, you don't need to take the free fall measurement first. You can take the measurement on the voltage first.
That might be easier because they can
Yeah.
pick the slow ones only.
Yeah. So because you have the luxury of actually rewinding here, so you don't need to actually do the free fall first, or we are actually kind of going back and forth between like no voltage and voltage.
Yeah.
Can you turn it on again?
Yes, but remember, when everything's going down, that means the voltage is off.
Can you turn it on
When
again?
the voltage on,
They
you
can
have some
take
going
one more
up
data
and
set.
down. Voltage on.
So let's have them take like one more data set here.
Well, that's some nice big ones going slow. Oh yeah. When we turn it off now?
Yep. Okay. And then let's try adding some ionization when the voltage is
Okay,
on.
let them get that data point with the
Yeah.
free fall first.
Yeah. Let's.
I can see a big one going slow, so let him go through.
So when that thing reaches down, can you turn the voltage on?
Tell me when. Oh, I see it. Yeah.
Okay.
That little one at the bottom,
Okay,
right?
go ahead.
Now, okay, go. And look how it's
And
going
now
up.
can you turn the ionization source? See what happens.
Okay, ionization source is off, but it's going on right now. You may see some of them change. It looked like one was going down, then started going up. Yeah, you'll see a little bit of that.
So again, we are not sure, but you can focus on more balls and then.
Yeah. I'm going to turn this ionization source off. Okay. Now remember, when the ionization source is on, that's not when you take measurements, because it's almost always off unless we say it's on and then off again, because the charge can change during that period. So be careful. Listen up.
Right. I mean, especially when the charge is like 7 electrons. If it goes from 7 to 8.
You want to add some oil and do a couple more runs?
I would think so. Yeah. Let's
Okay.
let them have.
Okay. Let me
runs.
add oil till we get a nice thick snowfall for Christmas. The snowing?
Oh yes. Good.
Oh, the field's on. Sorry. Field is off. Sorry. Field is off now. Okay, you can take data now. Field is off. Or do you want to start with the field on for their data?
Okay. Field is off right now.
Okay. Field is off. Everything's falling down.
Oh, some of them you could see actually on the very top, which is interesting.
Yeah.
See?
Yeah. The real bright ones are smaller, about wavelength of, well, yeah, they're about the,
So you wanna turn the field on now?
yeah, wavelength of light. Hang on.
Turn the field on.
Field is on now. Well, some of them really take off, don't they?
Yeah.
But some are moving pretty slowly upward.
Okay, let's turn
Field
it off
off?
now.
Field is off.
Yeah, you want to ignore the ones which go very fast. So now I think we can take some more data with this set.
There's some nice slow movers there. Falling slowly.
There's a large drop here which is falling very slow. So that one is interesting. Let's follow this one, see what happens to this large drop. Can you now turn it on now?
Field is on.
Oh yeah, so that large drop is a good data point.
Yeah, it's going slow.
Kind of slow. Of course, this one is going much slower here. So hopefully this one is only like one single electron here. It's going very slow. Is there any other slower ones?
Yeah, the one to the left.
Looks like this one is not
This one right here is going pretty slow.
Yeah. Some of them looks like they have
Turn it off again?
Charge on them.
Turn it off.
Okay, can you turn on the ionization source? See if this is gonna pick up any charge here.
Okay. Ionization source is on.
Let's see if this is gonna pick up any charges because it's falling right now. So I'm not sure if our ionization source is helping at all because this is still falling. It's a very small drop. Yeah, doesn't look like it's helping much actually. Okay, so I think.
Source is off.
So should we do like?
Field is on.
Should we do a higher voltage or?
Well, that data run was 261 volts.
Do you think that's enough to actually resolve a single electron?
I think they're going to get good data out of that, and it's already 30 minutes of data now, which
Right.
they're going to have to go back and forth over several times.
Should we show them what happens when we change polarity of the
Sure,
plate?
sure, we can do that.
Okay,
Let's
we need
spray
to
some
spray
oil.
more. Put it on spray position.
Okay. Okay, and hang on. Okay, there's everybody's falling now.
Well, let's have some free fall data. Okay, so we will now make bottom plate positive.
At 261 volts, 0.3.
It's okay, can you turn on the field on now?
Field is on.
Bottom plate positive.
Now.
So bottom plate positive. Now you can see some fast ones going downstairs and some slower ones going downward. Yeah, in principle, you could also use this data to calculate do the calculations. The only difference is when you turn the bottom plate positive, the rise and fall velocities in the equation, you need to subtract them rather than adding them. But that's the only difference. So
well, the rise velocity is actually negative.
Right. So it's basically the sign between the two velocities is minus rather than plus.
Yeah.
So now can we turn off the voltage?
Voltage is off.
And then if you wanna again use this bottom plate positive data one more time, we are gonna turn it on one more time, the voltage. Okay, I actually see some very nice drops here.
You want to go bottom plate positive or negative?
Bottom plate positive. So these are going very slow.
Tell me when.
Go ahead.
Bottom plate is positive.
Is it positive?
Yes. So rising drops are charged positively, falling drops are charged negatively.
So bottom plate positive right now. I don't see anyone's going down.
Yeah. Yeah. Well, we probably don't have a lot of. Looks like a lot of those oil drops are positively charged now, if they're going up. But it should be positively charged in integral multiples of electron charges. Yeah.
All right, but anyway, so you don't really need to take data with the bottom plate positive. So.
You want to do one more data run, a normal data run? In case they want more data?
No, I think they had enough data now.
Okay, field is off now.
I think they had enough data. So I don't think we need to increase voltage higher. Do you think so?
No, because we got plenty of good data in there.
Yeah, I think that's good.
You can if you want to do like a 400 volts for fun.
Okay, let's do 400 volts then.
Make sure you add the text.
Let's do actually 390.
Okay.
Because the maximum is, I believe, 400 on it, or
yeah.
Let's do 390 volts.
Make a note.
So we are now doing. I'm just gonna copy paste. How many?
Hang on.
Volts.
.6 or 391.5 volts. But right now voltage is off.
And top plate positive, right?
We're going to do top plate positive, yeah.
I hope they can hear you in the background.
I think they can.
Okay. All right. So can we put like can you
more oil? Right?
Right.
Adding oil now. Let me know when you see the Christmas snow.
Okay. Good. Very good. Stop right there. Very good.
Free fall. Drops are in free fall. When we turn the voltage on, you'll see some go up. It'll be under a positive top plate at 391.5 volts across the gap, which you measured in the video earlier. Tell me when, Dr. Surgeon.
Okay, so I think we are going to get some really nice data on this one. I see some very nice drops here. Go ahead, turn the voltage on, please.
Voltage on.
So we are going to get some very nice data here, I think. Okay, so
I see some slow ones. Tell me when.
Off.
Voltage off.
Okay, now free fall, and then we'll take one or two more data sets here. Let's wait maybe like 20 more seconds and then turn it on. Just gonna let these go through here. Go ahead, turn it on, please. No?
Voltage on, top plate positive, 391.5 volts.
Oh, top plate is positive right now?
Yeah. All these are all these are top plate positive.
Right. I'm not seeing anyone which are going up.
This guy's going up.
Oh, that one is going up?
Yeah. Well, we lost a lot of oil now. I want to do something else too when you're done.
That one's going up very slowly.
Data runs about over.
So, okay,
voltage off.
Voltage off. Let's see if we get more.
Falling down.
I think we lost all the oils drops here.
You want to do another?
Put more oil drops?
Yeah.
Okay.
Oh.
That's good. Good, very good. Very good.
Tell me when.
Some very large drops here.
Okay, free fall.
Okay.
Top plate positive now, 391.5 volts. Plenty of slow movers in there, find them. Those are your data.
There's one here which is very slow.
That's a little too slow probably.
Yeah.
Field off?
Yes.
Field is off now.
It's funny, it's going down much faster than it's going up. The slow one.
There's some big bubbles in there. They look to the left.
Yeah, I see a huge bubble here.
Let me know when field on.
I'm following this one here with my mouse.
Currently field is off. You know that because everything's moving down.
Can you turn it on?
Field on now. 391.5 volts. Some nice slow movers there.
Right, so this one is moving very slowly. So it could be that it only has a single charge. So it could be a good data point to actually capture a single charge. So the single charge is very tricky, right? Because the field on it is very small.
The force on it is very small.
Yeah, the force on it is very small.
Let me know. I'm going to go off.
Okay, Doug,
yeah.
the last thing I want to do, guys, listen to me. The last thing I want to do here, with this one that I'm following with my mouse, let's turn the bottom plate positive. The bottom plate positive, and then just give me a second. Let's turn the bottom plate positive, and then let's take a data run for this particular one with bottom plate positive, okay?
Okay, ready?
And just give me a second. And then when you do the calculation, don't forget to put a minus sign between the rise and fall
You want to turn
speeds.
field off now first?
Uh,
Field's on now.
turn it off.
Okay.
And then make the bottom plate positive.
Right now?
Yes, right now.
Bottom plate positive
We are
now.
losing it. We are losing it. Ah, we lost it. So
Went too fast.
turn it on again. The top plate positive.
Top plate positive now. 391.5 volts.
Let's see if we are going to get that thing back. That was an interesting one, but we lost it there because it was coming down near the bottom.
You want more oil? Go to zero field?
No, I think they had enough. So maybe they were able to actually get some data set on that last one with the bottom plate positive.
Okay, I want to do one thing.
Okay.
Okay, I'm going to turn the field off. I'm going to add some oil so we get that Christmas snowfall.
Mm-hmm.
Let me know. You see thick snow?
Yes.
There you go. thick snowfall there.
Mm-hmm.
I'm going to adjust the focus. So if I do it gently enough, you might see the bigger ones in more focus. See how you can see different size ones coming in and out of focus.
Because they're in different positions. Oh, the last one was actually in very good focus here.
Right there?
Just a little bit further, a little bit further. No, you went too far, I think. Yeah, but yeah, you can see them in and out of focus. Which is kind of nice. Oh, right there. You can see like a bunch of big ones there.
You want to get data there? Field is off.
Let's find a very slow one, and then okay, turn the field on.
Top plate positive.
Mm-hmm. Top plate positive.
Rising charges are negative. Falling charges are positive. Or zero.
Let me see if I can find one which is very slow.
Yeah, there's one right there.
So this one is kind of
It's
slow.
Let them get the rise velocity of that.
Yeah.
Rising speed.
And
Go a
then
few
and
more,
then
I'll
and then could you now turn it off?
Field is off.
It's falling.
Falling pretty slow too, right?
Yeah.
That's a good data point, guys. That's a good data point.
Can you turn the field on one more time?
Field is on. 391.5 volts. Top plate positive. Rising oil drops are negatively charged.
And then let's do this one with the bottom plate positive. See what happens to the same one.
Okay.
And follow me. I'll tell you when. Okay. So and then you do the bottom plate positive.
Okay.
Go ahead. Turn on bottom plate positive.
Bottom plate is positive. 391.5 volts.
Now you can see it's going down much faster. And again, you can use the same formula with the negative sign between the two velocities. Okay. So are we almost done here?
Field is off. Field is off.
Okay, field is off now. And then if you want to take a last data points for the
Snow is falling. Field is off.
Are we almost done?
We're almost done. Let's give them positive top plate one more time at 391.5 volts. Tell me when.
Go ahead.
Top plate positive, 391.5 volts.
There's one drop here, one drop here.
Yeah, there's some good
One
slow
here.
movers in there, sports
One here.
fans. Let me turn the field off again. Ready?
Yes.
Field is off.
By the way, you need to spend at least an hour here on taking data. I mean, this is a difficult experiment. You should be proud that you are actually doing this experiment.
Because we took a long time to set it up.
Not only that, but few universities actually do this experiment.
Yeah, yeah.
Good luck finding this experiment on YouTube. So we will be the first people to actually post on YouTube. I mean, I've been searching for this experiment on YouTube last night, Doug.
Animations only.
Animations only, exactly.
Nobody's actually doing it, yes.
And then we do the real thing here. We do nothing but the real thing, right?
Yeah.
So
we're good. We're good. That's a. You can turn. I think that's enough data.
Yes. Do you want to turn the voltage on one more time, or?
We can turn voltage. Top plate positive. 391.5 volts now.
I don't think we have many.
Any slow movers?
I think we're actually
I see
out,
a
out
big
of.
bubble.
Maybe. Yeah, I see a big bubble here.
Field
right.
is off. Tell me when to turn the field off. Now. Now.
Okay.
Field is off.
So I think we are done now.
Yeah, but let them see that drop you're
Yeah.
falling.
Yeah.
Let them see it fall.
Right. So I think it's this one, the large one here.
Yeah.
The large one.
Yeah. The two to the right are also slow.
Yeah.
Get some good data there, sports fans.
So you can take some nice data with these
the
large
Super
ones.
Bowl of the Millikan oil drop experiment right here in the arena.
The most complicated experiment we ever done, maybe? No.
I think like if they had to set it up, it would be too much.
Right.
We'd have to have it already set up and working, and each station would have to be already functioning. Field is off by the way, because you see all snowdrops are falling down. It'd have to be set up for them ahead of time, so when they walked in, it was already working, and then they could spend time.
Oh, there's a very nice drop. Can we turn the field on one more time here?
Okay, you want to let it go through a couple more?
Yeah, turn it on.
Field
now.
is off now, about to go on to 391.5 volts.
Yes, on.
Field is on.
Yeah, they can take a data with this one.
Oh, that's a beautiful one. Look at it. Oh, beautiful.
And
Feel
there,
it off?
and there are more here. Oh, just wait a little bit more. There is one more here. Yeah.
That's
and
top plate positive, 391.5 volts.
Turn it off. Turn it off.
Field is off.
Yeah, so we have some big drops in this picture here.
Let's let them get more data on the big drops.
Yeah. Oops, it's kind of getting.
I
out
see
of
it. I
focus.
see it. It's
you
falling.
can barely see it.
Want to change focus on it?
Okay, try that.
Other way?
The other way, maybe.
There it is.
I think we kind of lost that one.
Well, here's a nice slow one above that. Here. See these three? This one right here?
Yeah.
That's a nice one. Look at that. Follow that guy down. Follow him down. When he gets to that next dark line, he's still going down?
Yeah.
I'm going to turn the field on any second. Ready?
Yep.
Field is on now! 391.5 volts. Top plate positive.
Oh, that thing is still going down, unfortunately. But okay, I think they had more than enough data now, right?
Yeah, that's a lot of data, guys.
So, any final words here, or are we done?
We're done. Remember to stop starting your video to go to sections where, if you found the section where you got a data point, you can go back to that same section of tape for rise and fall and find a different drop. You can get lots of drops when the snowfall is heavy.
By the way, I should again remind that the goal of the experiment is not to verify that the electron is actually charges quantized, but you want to actually discover that, okay? So if there is an error in the experiment, you are not trying to circumvent through that. You are trying to basically look at the data and then make a conclusion on whether the charge is quantized or not. So the data analysis in this experiment is a little bit actually involved. You cannot just basically try to verify that, oh, the electron is quantized, we are done. You want to be able to do some good analysis here, take multiple data for the same oil drop, and then do it for as many oil drops as possible, so that we can actually have many different electron charges on many different oil drops, and then we can actually see whether the electron charge is quantized for real or not, right?
Yes, sir.
Okay, so now we are going to end the video then.
Good luck, guys.
Thank you, Professor Burke.
Thank you, sir.